Afternoon for you, I know. So it's a pleasure to be here to talk with you a little bit about computer graphics and also some programs we have at PUC. I'm going to talk about the university where we are. Actually, we are at home because COVID, but anyway. So my students are also participating today and they're going to talk a little bit about what we are doing. So I'm going to share right now to give you more information about what you're talking today. Please tell me if you are okay, probably now, right?
Yeah, it's
Yes.
good.
Yes, okay, perfect. So I am Soraya, my name is Soraya, and I am a professor at PUC, a university in the south of Brazil. I'm going to talk a little bit about it. And today we're going to talk about some projects in computer graphics. Specifically, I'm going to talk about a very nice project. I think it's very nice. It's crowd simulation. Probably you have heard about it in games or something like in movies. So I'm going to talk about that. And we are also talking about a conversational agent we are developing, which is the PhD thesis of Paulo, who is here today. And we are also talking a little bit about a program we have at PUC to have more growth in computer science, okay? So it's a movement in the world. We need more growth in computer science. So this is something we are also talking today. Okay. So just a little bit about the university. So here is Brazil. You certainly know, have heard about at least. And here is Rio Grande do Sul. And just in this red balloon, it's Porto Alegre. Porto Alegre is one of the most nice cities in Brazil. In the south of Brazil, we have snow sometimes. Currently, it's very, very hot. It's the summer. And this is PUC, so it's our university. It's one of the best universities in Brazil. We're very happy to work and study there. So this is a part of our campus. We have many, many undergrad courses and graduate courses. And inside computer science department, I coordinate the virtual human laboratory. So it's our lab. We work with all the stuff in computer graphics. So since we have images, it's a subject we can work with. So here I put some subjects: facial animation, analysis of faces, visual perception. Visual perception is a very nice area. The idea is to try to find out how human beings perceive things in terms of computer graphics images. Pedestrian behavior analysis. So we like very much to work with the simulation and analysis of behaviors of people, pedestrian, crowds. And today I'm going to talk a little bit about crowds. So let me count 2022. So 22 years ago, I was in Switzerland defending my PhD thesis, and my PhD thesis was in the subject of crowd simulation. I was the first PhD thesis in this area, so I'm going to talk a little bit about what we have done, what we are doing in crowd simulation in our lab, and also conversational agent, which is a very current technology. So many people start their business working with conversational agent. It's something very new and modern. So we are also talking a little bit about that. Just to talk about our team. So of course, in COVID years, I don't have many pictures, but this is one of the pictures we have recently. So at VHLab, we coordinate postdoc students, PhD students, master students, and undergraduate students. So Paulo is here, is a PhD, and Natalia is an undergrad student. Okay, so now I'm going to talk a little bit about crowds. My goal here is try to show you the importance of this kind of graphical simulation, which is performed in computers, okay? So first of all, what is a crowd, right? So crowd is when you have a lot of people, of course, but mainly the most interesting crowd is when you cannot see the groups anymore. So it's so many people that you cannot see groups, like, circles of people. You cannot identify groups anymore. So why is it interesting? Because there are a lot of problems that can emerge when you have crowds. Main applications: entertainment and safety and security. I'm going to talk a little bit about it. So, for example, crowds in films and movies. You certainly have seen movies or play games with crowds. So, for example, this in 1959. I was not born yet, so you were not yet here in the planet. So imagine that for this film Ben-Hur, they had 50,000 real people, 50,000 real people to coordinate, to put in the right place, to do where they should look in the right direction. And so it was very, very complicated. Star Wars. So Star Wars Episode 1, what we have? We have 350,000 agents. And then we start to call these little guys, which is completely made in computers. We call them agents or virtual humans, okay? And here we have 350,000 agents or virtual humans, and we don't need uh, to have a bathroom for them, or you don't need to have water for all of them. So imagine how hard it was to do this kind of movie in 1959. But even if you have a lot of applications in games and movies, in our lab, we are very interested about the safety and comfort and security of people. Unfortunately, sometimes we have some problems which emerge because you have a lot of people. So here, this image on the left, it was an accident which happens in Hillsburg Stadium in, I believe, 1989. More than 100 people died in this place where they were, because there are a lot of people and they crash and they have a lot of crowds problems. You can imagine that here the density of people per square meter was higher than 10 people per square meter. It's a lot. So the goal to have all this in computers is the possibility to simulate all these crowds and all scenarios you want to test before this kind of very tragic and sad situations happen. So there are many, many techniques. Of course, today I cannot talk about that, but just to give some technical, very small, few technical stuffs, there are two main approaches to simulate crowds in computers. One of them is to simulate person by person. So if you want to simulate 10,000 people, you have to simulate person by person. It means where the person A is, where the person A is going to, and the same for all the people in this 10,000 people you want to simulate. And the other approach people use a lot is try to have everybody like a fluid. So then there are many mathematics and equations for the people who likes mathematics. And the idea is try to find the pattern of this crowd behavior, simulated based on fluid equations and so on. So there are many, many challenges. I'm going to talk a little bit just to give you an idea about how difficult this area is. So for example, what's the distance between people? When you are now in the room you are seated, so you are in the distance of each other that you want, you feel comfortable with, right? And also depending on where the people put the chairs. But if you don't have chairs, in which distance you can stay from the others? You decide that or you don't decide? How is your trajectory when you walk to other locations? How you avoid collision with the others because you don't want to collide with the others, right? And how much these behaviors made in computers are natural. for example. How we put personalities in these people. So if you are playing a game, for example, and you want, for example, GTA, right? And you are playing GTA, and then you have people on the street. How these people behave themselves, how are their personalities, how you are going to interact with them. Are they natural? You can believe that it's a real person or not. Different levels of behavior, so you can have the behavior of one person or 1,000, and how it changes from one approach to other. Another interesting thing is very relevant right now. It's regarding COVID, for example. So in which distance people can have a kind of interaction that they can have COVID after some interaction. So cultural behaviors, how Brazilian people is in a public space, different from the people from Netherlands, I don't know. So all this kind of information we can put, and you should put in the crowd simulators, right? How we adapt ourselves to the spaces, how we can evacuate the environment. So if you have some fire situation right now at your college, what you are going to do? What's the first thing you have to do? And how we compare with the real life. How do we know that our methods in computer science are realistic enough in order to be used to take real decisions? So, guys, it's a lot of problems. And I started to work with crowd simulation in 96. In 96. And it's so many problems that I work until now with all these kind of problems. I just put some books, and also in my web page, I don't know how, I don't know if I put in my first slide, but certainly I can give you after. So you can find all the papers, scientific papers we have worked on. So these books, these two books I published with my supervisor, the professor who supervised my PhD at EPFL in Switzerland. And it was the first books in crowd simulation in the world. So in our lab, we have developed 3 softwares to simulate crowds. I'm going to talk a little bit about 2 of them, okay? This is important. This BioCrowds is available at GitHub. So if you know already how to program, and if you know what GitHub is, and maybe you are interested about, you can just send an email and we can share with you the source codes. So this is CrowdSim. CrowdSim was already tested in many real environments. So this is a football stadium in Rio de Janeiro. And we did this simulation in order to know if there is a fire situation or a panic situation in this stadium, in how many minutes people are going to be safe outside the football stadium. So I'm going to show you a little video. So here is one small example about how we program that. So we have an interface, and you have to define the place where people are going to board. The agents are going to start, and the goals of each environment, each agent. And then we simulate this. This is our building at PUC of computer science. So you can see the people walking. And of course, we are measuring all the time the people are taking in order to evacuate the environment. It was a nightclub here at Porto Alegre. This was the Olympic Stadium in Rio de Janeiro. It was, this stadium is for 46,000 people. So here you can see the people evacuating. And then we have this game. We developed a game. It was developed for a school here in Porto Alegre. They asked to simulate the scenario of an emergency in a school. And what we did is to develop a game at Unity, and then the students could see their rooms, the school, the best path in order to exit the school. And it was very, very interactive. It was a very, very nice project. We received many awards with this project. Okay. Sorry. So one scientific challenge you can probably imagine is, how can I say that these times, for example, I don't know, 112 or 119 seconds, it's okay in order to inform that to real people and people take decisions about this environment. So this is something very, very important. Here I just put a table in order to show you the challenge of that. So here we have all the information about the computer simulation. And here, real world data, we have all the information about a real case. So in this situation, we could simulate the nightclub scenario and also simulate in real life with real people. And it was very nice to see, for example, the total time is different, but it's normal because the real people, they were aware that it was not a panic situation. So people was not panicked, right? So of course, the time in real world data should be bigger than the time in computer simulation, because in computer simulation, we can put them very, very panicked. But this is very, very important in this kind of research. And I'm going to talk just a little bit about BioCrowds. This one is the software you can share with GitHub. So this software is based on, how can I say? I'm going to show the video. It's better to explain. So in this video, I'm going to show you BioCrowds. BioCrowds has this name, Bio, because it was based on an hypothesis which is used in biological context to explain the veins in the leaves. So yeah, it's a little bit crazy. You probably say, wow, but we observed that in nature, the veins in the leaves, they grow up, and they grow up based on the free space around it. So in this idea, we implemented exactly the same idea, but instead to have veins in the leaves, we have trajectories for people in the crowds. And here, just stopping a little bit here, this is very nice because this model, BioCrowds, it emerges a very low emergent behavior in crowds, which is the lanes formation. So lanes formation is when each flock here, each small circle here, it's one person, right? So it's more comfortable for this person, for example, this blue person, to follow another one who is going the same direction with higher or same speed. Exactly how we work in real life. And if you see, it generates the lanes formation. So it's very, very nice. It was the first method in computer science, in crowd simulation, who emerged the correct behaviors in terms of real crowds. This is also very nice effect. This arc formation, it forms this shape just in front of a door. So imagine that here, you can see the mouse, right? So imagine that here there is a door and everybody's trying to come into this door. But the problem is the door is closed. So in the real crowds, people study and they say that we form an arc just in front of the door. And we're going to see what happens here. So of course, the people there, they start to be more dense. The crowd is more dense. So people inside the arc, they have much less space around them, but it's a very, very beautiful arc formation. And also the bottleneck, for example, is another effect. And people are coming from the left to the right. And when they arrive here in these positions, they stop because they don't have space. The vortex, and that's it. Here I put a lot of papers, so I'm not going to in details, but all this information, all these papers, the figures, the pictures I put here is related with papers we have already published since 2007 until 2021. So please, if you like the area and if you want to read more about it, please send me an email. I'm going just to show you one example more specifically, which is a very nice example where we try to put our crowds in a stress situation. So here, I'm not going to talk about equations, but let's say that this is the original biocrowds. We change a little bit the mathematics in order to have a comfort model. It means you are evacuating the, I don't know, a nightclub, but you are not, it's not rushed for you. So you are okay. You just wait until there is a space for you, comfortable space for you to exit. So you can also do that. And if you want to stress more the people, so you also change more the mathematics to do that. It was our goal also to try to simulate the situation in Hillsburg, as I said before. This is some image where it happened, and this is how the people estimate in real life in this very sad situation the density of people. So what is density of people is the number of people inside a square meter. So here they have 10 people per square meter. And here are the results of our simulations. I'm going to show you a video. So like here, for example, it was people trying to go out, but without stress yet. So they are not stressed. Stressed when you start to fight for your life, right? So when you are not fighting for your life, you can wait a little bit, but then you start to be stressed, stopped in a situation that you cannot walk, and they start to pull people. And here where there is red agents, we measure, and there is 10 people per square meter. And then in this situation, the chance to have very tragic and sad events are very high. Okay, and just to finish here, because we want to talk about other things, but just to talk a little bit about crowd simulation, show you the importance of crowd simulation, I'm going to finish with a video. This is a very new project for us. We have worked to simulate our city here, Porto Alegre in Brazil, and to simulate the motion of people in order to find out the situation of COVID. So how people can be have COVID from the others, right? In the hubs, I mean, in the environments like supermarkets and I don't know, and in this kind of public spaces in which distance people are, how the people move inside the city. So we did this. I'm just going to show you a video. Yeah, no, I think I'm just let the YouTube, or maybe not. Yeah.
Grammarly Business offers AI power.
No, that's okay. I think we don't have time. I'm just going to send this. Probably you can have, I don't know, this PDF file, but here's the YouTube. And probably you can see after. So this was to talk a little bit about crowd simulation. I like to talk about that because I know that many people doesn't know that we have this kind of methods available to try to have these spaces more comfortable and more safe for everybody. So this is the idea. Okay. So now I think Paulo is started talking, right, Paulo?
Right. Can you hear me?
Yes.
Okay. So as I said, I'm Paulo. I'm a PhD student advised by Soraya. And I'm going to talk about The work we are doing our PhD thesis, which is the development of an embodied conversational agent, Arthur and Bella. So Arthur and Bella is an embodied conversational agent, but what is that? Basically, it's a virtual agent which talks with people, but it's not only like a chatbot, for example. It has an embodiment. It means it has a face, some also has a body, so it has some form of embodiment. And the main purpose of Arthur and Bella is to be a talking buddy. So to be a friend with which you can talk with about many subjects. It's also endowed with a human-like memory. So it has a memory model which is very similar with the way that humans think, the way we store our memories. It was developed using Unity, C#, Python, Prolog. It has a lot of stuff, and you can pass the slide. And exactly because it has a lot of technology, in fact, you can see, I put an overview here, it has a lot of things, a lot of modules which compound the embedded conversational agent. Of course, I'm not going to speak about all of that, we do not have time. So I'm going to focus especially on the two main modules, which is the memory model and the input model. Go on. So the memory. Basically, the memory used to store different data collected during the interaction with people and can be used later, the same interaction and other interactions with another people. To do so, we adopted a model known as autobiographical memory. We have an image in the next slide, which presents how the autobiographical memory is compounded, as proposed by Conway. So we can see it has three different parts: the lifetime period above, which is basically the periods in the time of a person, which occurs during the life; the general events, which represent the different events which occur in each period of time in the life; and the event-specific knowledge, which is basically a pool of different information, of different types of information, like images, audio, grammatical, and so on. Go on. So we model general events and event-specific knowledge. So general events are the events which occur during interaction with people. Event-specific knowledge are the details of each event. So for example, the Bella is knowing a new person. So it generates a new event. She knows a new person. She met Soraya, for example. And the details are the name, the image of Soraya, maybe another information about the life of Soraya when she asks, and can attach later, like her age, if she's working, and so on. All this information is stored in two different levels: short-term memory and long-term memory. Briefly, the main difference between short-term memory and long-term memory is the time. It means the time that information stays inside it. So for the short-term memory, it stays at most for 15 seconds, while in the long-term memory, it can stay forever there. Go on. About empathy, one of the definitions in the literature about empathy is the capacity to relate another's emotional state. So in the research in embodied conversational agents and even robots, we can see in the literature, there is a tendency to refer to a sympathetic, emotionally supportive, compassionate behavior as empathy. But all of this only reflects narrow fragments of empathetic behavior. Empathetic behavior itself is more complex than that. Go on. So for example, two examples of empathetic behaviors are affective and cognitive. So affective empathy is defined as the automatic, often unconscious mimic of other emotional states. Emotional behavior includes mirroring, affective matching. For example, if someone yawns, usually it makes other people also yawn. So it's an example of the mirroring. So also the affective matching. About the cognitive, consider the ability to understand the emotional state of other persons using cognitive mechanisms, perspective taking, theory mind, and so on. So it's a higher level of empathy behavior. Now we can go on. So to include empathy for Arthur and Bella, we also need to work with emotions, moods, boredom, and another things. To do so, we created a PhD class for Arthur and Bella. I'm not going to enter into many details here. So what's PhD? It's the pleasure, arousal, dominance traits. So it's 3 dimensions which are placed into a three-dimensional space, which you have here in the image. And depending of the values of those 3 dimensions, we're going to be in one or another stage inside the three-dimensional space. And it's going to reflect into his emotion. So the initial PhD is set based on the personality of the agent. So you also work with the personality model. We are using the ocean model. Once again, I'm not going to enter into details, but the ocean model is also known as the Big Five model, largely known in the psychology field. The boredom increases in a linear way, and we use the boredom to calculate both the mood of the agent and to make the agent becomes bored. If the interaction becomes cold, the person stops talking with the agent, and so on. And the PhD can be updated in 3 different situations. When the user says something, so when the user is talking with the agent, the emotion recognized by the face of the user, so the person which is talking with the virtual agent appears at the webcam, and his face can be analyzed to infer some emotion. And when something is remembered, when the memory model is triggered and a memory is recovered from the memory. Now I think it's Natalia is going to do her presentation.
Hello, everyone. I am Natalia. I am an undergraduate student at UWC. I also work as a research intern with Soraya and Paulo at VHLab, and I work in the project he just presented, which is Arthur and Bella. Soraya and Paulo were talking about some trends that are occurring in the computer science world, and I think one of the most relevant ones currently is that companies and universities are really trying to get girls to join programs and to really learn to program and join computer science courses. You may wonder why this happens, why companies sponsor scholarships for girls, or they teach programming in schools. And to explain that, I have to give some background information about Brazil. I know this happens globally, but the statistics can be a bit different for each country. But overall, we have less women in the computer science field. For example, in 2019, according to the Brazilian census, only 13.3% of women were enrolling into the IT courses. This is the least percentage of women in any field of study. We also had less than 30% of women making up the workforce in technology. So we have the tech field, which is really growing, and we need workers. We don't have enough people to fill the jobs we have open already. And we are losing like half the population because women are not getting into technology. So next slide, please, Soraya. With the intention of getting girls to join computing, the program Women in Computer Science was created. It is a collaboration between Poatec and PUC-RS. Poatec is a growing tech company that has offices in Lisbon, Miami, São Paulo, and Porto Alegre. Its headquarters is in Porto Alegre. And PUC-RS, also located in the south of Brazil, is considered the best university, private university in the south of Brazil by the Times Higher Education. Sorry, next slide, Soraya. This is what I was talking about, I'm sorry. I am one of the women who was awarded the Women in Computer Science program. And I really believe that the partnership between the industry and the university makes all the difference. We are awarded a scholarship for our full tuition. Each year, a few women who apply to the bachelor degree in computer science at PUC-RS are awarded this scholarship. And beyond the financing for our tuition, we also receive the academic support from a professor. We are in constant contact with her. In my case, it's Soraya. I can come to her with any questions I have about university, doubts about my professors, what I'm going to take next semester, for example. And we also have the support from Platec. They offer us a mentor, one of their employees, and they can help us with curriculum, planning for our next internship, planning for our career in general. Next slide, please. This is my favorite part of the program, the one I'm most excited to talk to you about. Beyond all the financial help for our scholarship, we also receive a monthly stipend that helps us to focus on research in PUC-RS. Next slide, please. Soraya. I have chosen to join Soraya and Paulo at VHLab, but each girl can choose to join a laboratory on a topic that they feel drawn to. We have labs on virtual reality, computer intelligence, cybersecurity, the VHLab, which is human simulation, and each student can choose the one they prefer to join based on their interest. This is very beneficial to us, I believe, because it allows for the integration with master's and PhD students. I remember my first week at the lab, I was seeing research by Paulo for the first time, and I was not very familiar with the rigorous academic research process that they go through. So this is something I'm learning very early on. I also believe it is very beneficial to us in the sense of encouraging us to look beyond our course curriculum. Like my first semester at PUC, I learned a lot. But when I joined the lab, I really had to research on my own. I was hearing for the first time terms I had never heard before. I also was reading papers that I knew nothing about yet. And this really propelled me to search on my own. I had to study alone. And I think that this ability of being self-taught and learning on your own is essential to any student, but especially for people who want to go into research, because you have to be creative, you have to explore on your own. And I did this, my first few weeks were learning alone, searching subjects I had no familiarity with, but I had the security of knowing that I could turn to someone in the lab if I had any questions. Like if I was searching something and I really liked it and I couldn't find more resources, I could come to Paulo and say, oh, can you tell me more papers that I could read? And this was the best part about joining the lab. Next slide, please. Well, to talk about the program in terms of numbers and the impact we are doing, we have currently 9 undergraduate students at the PUC program for computer science, and 1 master's student in the computer science graduate program as well. But more than this, I believe that we are not just numbers. You can pass the next slide. I put some photos of the girls here because I really think that this program is inspiring in the sense that each one of us really understand the value of bringing women to computer science. Like Soraya was talking, computer science is all about solving problems. We have problems that go on for 20 years and we have to really think them over. And I think the best way to solve the problems we have now is to bring like diversity and different people to think on them. We need intelligent and creative people joining. And by taking women out of computer science, we are half of the population. And we have different ideas. We think differently. So I think that each one of us on the Women in Computer Science program really values this and takes to heart that we have to bring more diversity into tech. And more than studying and completing our coursework, we really want to encourage other women to learn programming. Even if you don't join a bachelor in computer science, you can still learn programming. It's very fun. And it is a field, like tech field has a lot of jobs and opportunities. So here's all undergraduate students, and we have one more, but I couldn't ask her for her picture. That's it. And
okay.
I left my mail in the next slide. If anyone wants to talk about the program or in general, if you want to talk about computer science and feminism and women joining computer science, I'm really happy to talk about it.
Perfect. Thank you. Thank you, Natalia. Thank you, Paulo.
Thank you all so much. Unfortunately, I think I'm pretty sure we have a lot of questions in the audience, but yeah, I'm not sure if we have time for that. Maybe top 1. I don't know if someone would like to ask something, or if for Soraya, Natalia, and Paulo, if it will be okay to share your emails with the students, and then they
Sure,
can send
sure.
you the questions because of the lack of time.
Sure. Maria, how you do that? Well, here in the slide, there is the Natalia's email, and I don't know if I can put in the chat here.
Perfect.
Paulo did already, okay.
Great. And thank you so much. It was very interesting. For everyone who may want to have another look, I'm going to send you the video and the presentation and all the emails so you can contact them directly for more questions. Thank you all so much for joining.
Okay. Thank you for the opportunity to talk with you about this subject. And please send an emails or access the VHLab, Instagram. Also, I'm going to send to Maria if you want to know what we're doing. We have videos on YouTube.
Great. Thank you so much.
Okay.
Thank
you again, Maria.
Have a nice day, all of you. Thank you for joining us.
Thank you for having us.
Bye-bye.
Thank you all. Bye-bye.
Bye.
Thank you.
Thank you.
Bye-bye, guys. Okay, bye.
Bye-bye.